All right, everyone, welcome back. While they're getting set up, I'm going to go ahead and introduce the next talk and introduce you to our next speakers. So as promised, our previous session was beyond the demo, and now we are going beyond vibe coding. So I hope you are looking forward to this presentation. Please welcome to the stage Maximilian and Abdul.
Thank you. Hello, everyone. Hands up for everyone who used vibe coding for creating a CAP application within the last month. Those are not too many. I expected more of you. Maybe you're already asleep. And who of you used spec-driven development? Some of you. I hope some more arms will get up if I ask the same question in 1 month again, because you get inspired by what we did or what we are going to show you right now. Before we start, what is the plan for the next 20 minutes? Now it's maybe only 17, but we will see. So I will start with the theoretical introduction about the topic, and then the brave man next to me will going for a live demo on conference Wi-Fi with non-deterministic AI. This hopefully will go well. Before I can start, I have to make a confession. I know slides are not the love language of the CAP community, code is. But I brought some slides today, but to make it more bearable, I designed them as VS Code, so it's more like a code review and less of a slide implementation. And also, it's already 4 p.m. I know you're getting tired, you're thinking about the first beer in some minutes, and you may be falling asleep, so it's best if you can look at something which is moving, so it's come Subway Surfer for you, so you get energized. Okay, so now let's get started with the theoretical stuff. As you all know, what we like most is staying in our dark room, coding, building something great. Don't talk to anyone. We like that one. But the industry doesn't like that one. The industry doesn't like happy coders. The industry wants to make us sad, and therefore they introduce something like pair programming. 2 people fighting about 1 line of code for 20 minutes. Everyone hates that. So what came next? Test-driven development. We are hating writing code. We're hating writing tests. And test-driven development is even worse. We start with the test and we not even have any code right now. Next, Scrum, refinements, retrospective, meetings. But what are we not going to do? We're not going to code anymore. We hate this as well. And now, what do we hate even more than writing tests, writing documentations? And this is what spec-driven development is all about. We are now going to start writing a documentation before we even going to write any code. And at the end, we're not going to write code as well, because this is going to be done by the AI. Nevertheless, you might be not be hyped about it. I will introduce it to you anyways. So, why is vibe coding not enough, and what is vibe coding about? Vibe coding means we are writing a code, we are generating something, we are not looking at it, we are never looking at the code, but we're looking at the results and we are happy. And it works out in many cases. In some cases, if you want to build something which is only a small project, then it works perfectly. But the issue is, if we run the same prompt 100 times, we're getting 100 different architectures. It's basically like a slot machine with a JIT integration. And this is something we don't want. It works out, we have a vibe peak, but if it gets more complex, if we have like S4 integration, success factors integration, if we want to do something more, authorization, transactional handling, then we're starting to getting slower. And that's not just my gut feeling. There are studies about this which show that if you have a really complex system and you have really good developers and they have to implement a feature, they need 20% more time with AI than without AI, because an AI can implement 10 bugs within 3 seconds, and you are going to fix them for 2 days. And therefore, we need something more. We need vibe coding. We need something more than vibe coding. We need spec-driven development. And spec-driven development starts with a specification. So you're going to document what do you need, why do you need it, what are your acceptance criteria, what are your edge cases. And this is your single source of truth. You compile more or less your code from your specification. And this is a bit different to the traditional coding. For sure, we have the traditional software development lifecycle where we also have a specification. But what is the specification? We are doing something in Java, being proud of ourselves, and we never look back. And this is not going to happen with spec-driven development, because the spec is always the single source of truth. If we want to change something in our system, we have to change the spec as well. So how does it work in detail? First, it is one workflow with 5 different artifacts. The first artifact is the constitution. The constitution holds all of our undebatable rules. So if you want to make Daniel Hutzel unhappy, you write, I'm always going to use object relationship mapping, never use something else. Yeah, just kidding. You normally would write things like, if you write a handler, always write a test for it. This is the baseline, and you normally write it only once for your project, maybe update it from time to time, but not on a regular basis. After you have your constitution, you have to specify your features, the what and why you want to build it. No tag, just user stories, acceptance criteria, and edge cases. Once you have that, you're going more into detail with your plan. This is really the how, the data model, the CDS, all of that, the service design, the annotations. At the end, your plan is checked against your constitution. If your plan says you're going to use an MongoDB, but your constitution says just CAP only with HANA Cloud, this won't go well. Therefore, your plan is always checked against your constitution. Once you have your plan and your requirements, you need tasks. Tasks are atomic, verifiable work items, really small work items. And with them, you're going to implement. So the really difference here is you have a normal software development lifecycle, but you're not going to implement it yourself. The AI is going to implement it for you. Those constitution specify plan task implement are the vocabulary of the GitHub spec kit. There are many implementations of the same workflow. There's get the shit done, Kiro, OpenSpec. They have different names, but the workflow doesn't change. It's always the same. And there's one good thing for you guys. If you use CAP since the beginning, since 2018, you're more or less doing spec-driven development, because what is CDS? CDS is not coding. CDS is a specification of your data model. And this is also the reason why spec-driven development and CDS work very well together, because you do not have to translate a lot. If you're saying, I want to have drafting, you write or you annotate OData draft enabled, but you don't have to implement it. And this is already spec. And therefore, specifying in plain English and getting a CDS is not that far away, and therefore it really makes sense to bring those two words together. And now, enough talking and more live demo.
Okay. Now I will try to show some commands, and also, if we have time, I will also try to implement one of the requirements into the application. I think it's good. So, when we have a new project, we should first start defining the constitution, as Max explained. And it is very critical to define all the requirements, all the standards that we want to follow. Actually, AI needs to follow during the development process. So we need to define very detailed constitutions here. So I have a sample constitution command here. It is actually a long one, and when you are working on a real project, it will not be created in one shot. You will always add new definitions into the constitution during the work, because sometimes AI will do something different than you want. So you need to update the constitution every time if you see something wrong happening in the results. So this is a sample constitution. As you can see, I'm defining some technology framework and definitions, like I'm going to use Node.js, and I need to use SAP CDS library, and I will use OData v4, and I want to use SQLite for local development. And this is critical part. I am always adding this information into the constitution. I need to use MCP servers all the time. It should be the first point to get the information. If there is not enough information, then AI can go to the other sources, but this is the mandatory part that AI should check first all the time. And I'm putting some additional details here, and then for the front end, I am adding like it should use SAP generator Fiori. Sometimes when I was using SpecKit, it was generating Fiori applications from the scratch, but it was not complete. So I just added this to use the generator instead of creating manually, and I need to use Fiori elements, and I need to use test-driven development in the application. And when using SpecKit, it was always trying to create new features, new branches, but in my project, and I think it will happen all the time for everyone, we need to stick on some branches in our Git repository. We need to stick on some naming conditions. So I didn't want AI to create a branch automatically. That's why I added this part. So it should always stay on the existing branch. If there is really need to create a new branch, then it should ask to the user before going through. And also, when we are using SpecKit, it is creating user stories in the spec MD file. But when working on a big project, it grows a lot, and I wanted to split all the user stories into separate MD files in a separate folder. It will make our life much more easier instead of going through the single spec file. That's why I added this user story constitution. And I put some formatting details for the user stories. Actually, these are put because when we are working on a real project, we are actually using some other tools like project management tools to create a user story. We are doing lots of meetings with the business, and we are updating the user story. So I wanted to have a similar user story structure on the project repository so that I can copy and paste all the time when there is an update in the details. So after providing this constitution, I am not going to provide to the AI directly, and I have already created a branch for this. And if I open the constitution file, is this? Specify memory constitution, here it is. So after providing this command to the AI, it is actually generated this file. The details are CAP technology stack, MCP details, generator, first front end, test-driven development, etc., etc. So it is actually documenting all the details I am providing. So whenever I provide any command to the AI in the later phases, it is always using this as a first point of information, then it can do other works. But this is the rules that it is always going to follow. Then on the second step, we are providing the, let me go to the second command. We need to specify the business requirement here. Here we don't need to provide any technical details, only the business requirement. I took the example of the bookshop application, which is a simple one, which everybody knows. There is a books entity, authors entity, maybe orders entity. So it is very simple one. So we need to we need a simple bookshop catalog where users can browse books and see who wrote them. We need to track how many copies of each book we have left in the stock, etc., etc. So I'm providing very basic details, but in the real life, we are providing lots of details, and even we are doing lots of iterations with the business. We are getting new requirements and updating the specifications. So it is not like we are doing this in 1 hour, in 1 day. It is actually happens during the project lifetime. So when you are starting a new project, normally you go and have lots of meetings with the business, and then go back to your project management system, create the user stories, and you have to update your specification in parallel in your project. Even there is no any code, you need to have a functional specification and technical specification inside your repository that AI can understand. So when you start your implementation, you don't need to provide all the details from one document to the AI. Actually, this is the main power of the spec kit that I like. So after we specify this command to the AI, then we are getting a spec folder. Let me switch to the second branch. We have a specs folder, and it creates one feature, bookshop catalog, and then inside this catalog we have a spec MD file. This is generated after this command, and if I open preview, you can see that we have a user story one for browse book catalog. It has details, it has user story 2, edge cases. This is actually a summary. If you go to the user story folder, you can have more details in the for each user story, and there are business rules, acceptance scenarios. These are already defined in the Constitution. It should add positive cases, negative cases, edge cases, dependencies, assumptions, etc. So we have now user story details for each user story. Then we can switch to the third step, which is a planning part. In this planning part, actually, the functional requirement is converted into the technical details. Here we need to provide some technical details to the spec kit so that it can use MCP servers and other resources to create a technical plan and generate a data model. And as you can see, I am providing not much details. Backend is based on SAP CAP with Node.js, UI based on Fiori elements and SQLite and HANA. Then we will have some technical details inside our repository. In the feature folder, there's a plan file. You can see the technical context. There are lots of technical details, some constitution checks. It is actually doing some checks with the plan and making sure that everything is followed with the constitution. It is creating a project structure, file structure, etc. And then what other files we have? We have a data model. According to my definition, it is now created a data model. We have an author entity. We need to have name and books and association to many books for the authors, and for the books we have association to one author because I have defined this in the business requirement part. Then you can see that we have too many technical details, which is actually ready for the implementation. And after this step, we can start our implementation, but we are not saying, okay, you can implement this project. Instead of this, we need to create all the specifications into a technical task. So we can implement phase by phase and then we can verify, we can review, we can update some codes because it is not generating 100% correct application all the time. So we need to review all the time. So if we go to the I think I have some uncommitted parts and I'm not moving between the branches. Anyway, and after this part, I need to provide a simple command, break the plan into implementation task. And then after this spec-kit task command, you can see that I have a task list to implement, and you can see I have T0, 1, 2, 3, 4, etc. Let me commit this one. Now it is empty. So we have phase 1 to set up initial infrastructure, and then it is created a phase 2 for foundational details, and phase 3, phase 4, etc. So instead of implementing all the phases in one step, I usually prefer to implement each phase separately. Sometimes even I implement some tasks as a separate implementation just to make sure that it is implemented correctly. And by the way, I can also show that when you initialize, I think I should explain this in the beginning, but when you want to use the spec-kit for the first time, you need to install the specify CLI into your workspace, and you can install with one of these commands, and then after installing, you need to initialize your project with specify command. Specify init and then name of the project. I can show you one sample here. Specify init bookshop reCAP. And after you provide, it is asking you which AI tool you are going to use. In my case, I am using Cloud. And you need to select which script environment you are using, shell script or PowerShell. When you install, when you initialize spec-kit, and it is actually creating lots of file inside the cloud folder. There are some agent skill definitions, and there are some scripts, and that is using during the implementation phase. And after I select my shell, then it is ready. And if you go to your Cloud Code agent, if you write /spec-kit, you can see that there are lots of skills you can implement. And after this, all the steps, I have one final implemented application. Unfortunately, I don't have enough time to implement live on the stage, but if I run CDS Watch, this application is generated without any single line of code written by me. Everything is generated according to my specifications. And if you open the application,
We forgot to specify that it should work.
it was working. And we have a books application. If you go into details, that's the basic details, but authors was also working anyway. Yeah, it is working now. If you go, you have the books associations, and if you open the, for example, data model, you have entity authors, entity books, which is very correct according to the best practices from the MCP servers. I think we have already out of time, so maybe we can have time for the questions.
Unfortunately, there's no time for questions. We have our next session coming up in 4 minutes. I hope you're looking forward to ClickOps to co-ops with Terraform. Let's, in the meantime, give these guys a nice round of applause for their presentation. Thank you very much. And hope to see you at 4:30. Thank you.
Thank you.